Earlier we have looked at the first energy storage element, capacitors, and we have seen that how we can analyze the different analysis of the capacitors. For example, voltage is given, how we can find the current is given, voltage, power, energy, and all those. Now let's have a look at the second component, which is basically an inductor. So inductor is also basically a device, that will stores basically the energy, okay, which is basically in the form of magnetic energy. For the capacitors, it was basically electric energy, but the inductor that stores basically the magnetic energy. So how basically inductor works? So you just need to take a simple wire, and make some coils of that, simple, and that will form a basic inductor with the symbol we represent using L. The unit of inductor is basically Henry. The unit of capacitance was basically Farad. All right. Now, if you supply some voltage, the battery to this one, so a current will start flowing through this inductor. So when the current flows through an inductor, it will generate basically the magnetic field, around that, like this. The current is flowing through this inductor, and now we have these magnetic field lines, which are also called as flux lines. And these flux lines basically stores the magnetic energy. Inductors are also available in the variety of sizes and cases. For example, this is a one filament type inductors. This is a kind of ferrite beads inductor. This is a typical small transformer, that is basically used in your mobile charger, for example, to step down the AC voltage to a low voltage. So there are a lot of other application, for the inductors. For example, a common heater which is used in the household applications basically has a typical inductor. So the circuit representation of inductor is like this one. We draw a kind of a coil, with this form, simply like this, and the inductance representation is L. The formula to calculate voltage currents are kind of similar to the capacitors. For example, the voltage drop across inductors can be calculated by multiplying the inductor value with the derivative of the current flowing through it. So if we know the current, if you know the voltage and you want to find the current, so that will go to the other side, so 1 over N, then we just take the integration of the voltage. So this is similar. So like in the capacitors form, if you will remember, the voltage drop across the capacitor was what? Initial voltage plus the actual voltage, right? So basically 1 over C integral of current. Similarly, we have the current through the inductor. That will be initial stored current plus 1 over L, the actual current that is flowing through the inductor, because inductor like capacitors can also store the energy initially also. So power is basically just multiply the same concept, voltage multiply with the currents. So energy stored, it's a similar fashion. For the capacitor it was 1 over 2 C voltage at T2 square minus voltage at T1 square. So for the inductor is same, half, replace the C with the L, replace the voltage with the current. So if I write down here, it will be very similar, half L. Instead of voltage, use the current. So T2 square minus the current at T1 square. And we have basically the energy. And if the second, like the first time interval is 0, so this thing will become 0, and our formula can be simplified to this form. So these are the basically typical formulas that are used for the analysis of the